This video is for class 9 physics, and we are doing the numerical problems on upthrust from exercise 5a, right? So let us go through the formulas quickly before starting the numerical problems. The first one is FB equals to V rho G, right? Where FB stands for upthrust, V stands for the volume of the object immersed in a fluid or the volume of the fluid displaced, right? Both are same. Rho is the density of the liquid or gas, and G stands for acceleration due to gravity, right? So if it is total upthrust, then instead of F we should write FB dash, whose formula will also remain same, right? And if we are considering the weight of the object W, right, suppose we are considering the weight of the object W, so W should be also equal to V rho G, but this time it should be the density of the solid. Okay, so I hope you understood this formula. The next one is known as the apparent weight, the weight of the solid inside the fluid. The apparent weight should be equal to the weight in air minus the upthrust acting on the object. This upthrust can be the total upthrust or it can be FB only, it depends, right? Next, note, few notes are also there. Volume of the submerged part of the object should be equal to the volume of the fluid displaced, right? We have studied this. Okay, this plays a very vital role while solving the numerical problems. The next concept is when whole object is submerged, when the whole object is submerged, then the volume of the object should be equal to the volume of the fluid displaced, and the upthrust will be FB dash because that's the total upthrust, that is the maximum upthrust. Okay, so the numerical problems will be easier if this condition is given. If the body is totally submerged, then the volume of the object and the displaced liquid should be same. Okay, let us start solving the numerical problems. Let us go to question number 1. So coming to the first question of the numerical problems from exercise 5a, let us go through the question. A body of volume 100 centimeter cube weighs 5 kgf in air, right? It is completely immersed in a liquid, so volume should be same of the displaced liquid and the object. Of density 1.8 into 10 to the power 3 kilogram per meter cube, right? This here. So this is the density of the liquid. Find the upthrust due to the liquid and the weight of the body in the liquid, which means apparent weight. Okay, let us try to solve the question. Coming to the solution of number 1, given volume which is 100 centimeter cube, I am converting this 100 centimeter cube into meter cube by dividing this 100 by 10 lakh, right? Now the other thing which was given to us is weight in air, which is 5 kgf, and the density of the liquid, which was 1.8 multiplied by 10 to the power 3 kilogram per meter cube. Now I am supposed to find the upthrust. To find the upthrust, I shall use the formula for upthrust, which is V equals to which is FB dash equals to V rho G. Now FB dash equals to V rho, I can just use this. Where did this G go, right? If upthrust is to be calculated in kgf or gram force, right, then I can simply use V into rho. Okay, we don't have to use this acceleration due to gravity. This is for finding the upthrust in Newton, right? If I multiply this value by 10, I should get the answer in Newton. Now this 10 should be the value of acceleration due to gravity. So if I am not using acceleration due to gravity, then simply I will get the answer in kgf, which is an easier option. Now replacing the values of V, which is 100 upon 10 lakh multiplied by density, which is 1.8 multiplied by 1000, and doing the calculation, I shall get FB dash, that is the total upthrust, equals to 0.18 kgf. Now coming to the next part of the question, the weight of the body in liquid. The weight of the body in liquid should be equal to the apparent weight, right? Now apparent weight is equal to the weight in air minus upthrust. Now weight in air was 5 kgf, upthrust we just calculated to be 0.18 kgf. Now finally after subtraction we shall get 4.82 kgf. I hope you have understood the solution of number 1. Let us go to the next question, which is question number 2. So coming to the next question, which is question number 2, a body weighs 450 gram force in air. So weight in air is 450 gram force and 310 gram force when completely immersed in water. That means this is my apparent weight. Now find the volume of the body, the loss in weight of the body, and the upthrust. Now this loss in weight and the upthrust should be same, right? Let us do the solution. So coming to the solution of number 2, weight in air given to us is 450 gram force, weight in water is 310 gram force. Now upthrust should be equal to weight in air minus weight in water. Now that is, this is the apparent weight, okay? Now FB, that is upthrust, is equal to 450 gram force minus 310 gram force, which is coming up to 140 gram force. So my third part is done. Now the loss in weight. The loss in weight is supposed to be equal to the upthrust, which is also 150 gram force. Now as you all know, upthrust should be equals to V rho G. Now 140 gram force, if I am using gram force, I don't have to use this G again. So it just becomes V rho. So I hope you understood where did this G go, right? Now 140 gram force is equal to V, rho's value is 1 gram per centimeter cube. This is our assumption because we are assuming the density of the water to be 1 gram per centimeter cube. So therefore V after cross multiplication will be 140 gram force upon 1 gram per centimeter cube, which is finally giving me 140 centimeter cube. I hope this is clear, right? I can go to the next question, which is question number 3. Question number 3 reads as, you are provided with a hollow iron ball A of volume 15 centimeter cube. So there is a hollow iron ball, okay, whose volume is 15 centimeter cube, right? And the mass is 12 gram. And a solid iron ball B, there is another iron ball B of same mass, which is 12 gram. So obviously this ball B should be smaller than ball A because it is solid, right, of the same mass. Both are placed on the surface of water contained in a large tub. Find the upthrust on each ball. Which ball will sink? Give a reason for your answer, right? So we have 3 questions. Find the upthrust on each ball. Which ball will sink? Obviously whosever weight is more than the upthrust, that particular ball should sink. And give reason for your answer, okay, because the weight of the object will be more than the upthrust. Okay, let us go to its solution. Solution number 3. Volume of the ball A given to us is 15 centimeter cube. Mass of the ball is 12 gram. Therefore, the weight of the ball should be 12 gram force. I hope you know how to convert the mass into weight. Now, upthrust on the ball A should be V rho G, which is 15 centimeter cube multiplied by 1 gram per centimeter cube. The density of the water is assumed and multiplied by acceleration due to gravity. If I want the answer in gram force, this will not have any role, that is acceleration due to gravity will not have any role, sorry. So after multiplication we shall get 15 gram force. Since the weight of the ball, which is 12 gram force here, is less than the upthrust, which is 15 gram force here, right? So this body will float, so ball A should float. Now for the ball B, volume of the ball B is not given, right? Mass of the ball B is same, that is 12 gram. Weight of the ball B is 12 gram force, right? So density of iron which is given to us, which is 8 gram per centimeter cube. Using this density I can calculate the volume of the ball B. Why I need this volume? To calculate the upthrust. Now volume should be equals to mass upon density. This we have already studied in class 7, so I haven't mentioned it in the formula section also. As you all know, density equals to mass by volume, so volume should be equal to mass upon density, right? Now for the solving it, replacing the values of m, which is 12 gram here, 12 gram upon 8 gram per centimeter cube, I shall get 1.5 gram per 1.5 centimeter cube. So upthrust on the ball B can be calculated using the formula again V rho G. V we calculate it to be 1.5 centimeter cube. The density of water is 1 gram per centimeter cube, and this G, which is acceleration due to gravity. Now after solving it, we shall get the answer in 1.5 gram force. I hope you understood the rule of this G, right? Okay, since the weight of the ball is greater than the upthrust, because weight of the ball was 12 gram force, the upthrust on the ball is just 1.5 gram force, hence the ball B will sink. So I hope you have understood this question number